Okay, let's look at another example. So a car is 200 meters from the intersection and it's traveling at 30 meters per second. If it accelerates at 5 meters per second squared, what's its speed when it gets to the intersection? So what's challenging about this problem? Well, the first is we're not being asked for the time when it gets to the intersection, we're being asked for its speed. And so we're going to have to get a little bit creative about how we do it. But it's no different than the other situation. We simply say the thing we don't know is time. We isolate for time and then rearrange the equation. And with a little bit of manipulation, our final speed squared, what we're trying to find, equals our starting speed squared plus 2 times the acceleration times the distance to the intersection. And from that we can quickly get our speed of the car as it enters the intersection. And essentially any of these problems could be solved that way. We just need to identify what we've been given and what we need to calculate, and then find the equation that relates those variables. Now, you're not going to be expected to isolate those variables every time. You have your formula sheet, and you just need to pull out the equation that's already been done for you from the 5 equations of motion and use the appropriate one. Okay, let's try an example in anger here. So a sled's sitting at rest and is accelerated at a rate of 2 meters per second squared for 3 seconds. How far does it travel during those 3 seconds? Again, not our typical thing. We'd be asked, in the simple acceleration problems, we'd be asked what's our final speed. We're not asked for the final speed, we're asked for the distance. So, our givens, v1 of 0, acceleration of 2 meters per second squared, and our time interval of 3 seconds. Our unknown is how far it travels. So we can go back to our formula sheet, find the appropriate formula, and it's the one that we derived earlier, of course. Delta d equals v1 delta t times 1/2 acceleration times delta t squared. Substitute in, and we get 0 for our v1 plus 1/2 2 meters per second squared times 3 seconds squared. Cancel our units and get meters, 9 meters. Okay, there's plenty more problems for you to work through over the weekend. Please start working through homework set 3, the equations of motion, and we'll meet back up next week. And please don't forget, you need to bring your design for your catapult, proposed design for me to approve. Thank you and have a great weekend.